Okay, so we have this preference schedule, and it says, does this example illustrate that the plurality method violates the majority criterion? So before we can start, somebody remind me what the majority criterion says. Yes, Ryan.
When you have the majority of plurality votes being
Right, it says that you should be an automatic win, right? If you have more than half the votes, you should get an automatic win. So we have to determine if someone has more than half the votes. So how many voters are there in this election? 55 votes, which means I need more than half for a majority. Half of 55 would be 27 and a half, so I need 28 for a majority. Oh, thank you. Should have added it myself. So to get the number of voters, you add the numbers across the top in the preference schedule and you get 36. Okay, so half of 36 is 18, but a majority requires more than half, so we have 19 for a majority. Okay, so let's determine the winner now using the plurality method. So with the plurality method, you just count first place votes. So how many first place votes does A have? 20. And B, and C, and D, 3. Okay, so who's the winner? A. Okay. Now, we've determined the winner using the plurality method. Now we're going to check the majority criterion. Is there a candidate who has a majority? Yes, candidate A. Did candidate A lose? No, then we have not violated the criterion. The only way to violate the criterion is if you have a candidate that has a majority and loses, right? But candidate A has a majority and wins, so we have satisfied the majority criterion. So this does not demonstrate a violation of majority. Yes? Mm-hmm. Well, that wouldn't be possible, because if A has 20 and B has 21, then that's a total of 41 votes, and we only have 36. There's only 36 voters. So the idea with the majority is only one person can ever get a majority, because it's more than half. So if you have more than half the votes, no one else could have more than half, because there are less than half of the votes remaining. So we have no violation here. So the next question says, does this example demonstrate that the plurality method violates the Condorcet criterion? So somebody remind me what the Condorcet criterion was. Yeah, Calix. Head-to-head matchups. If anyone is undefeated in their head-to-head matchups, they should automatically be a winner, right? They should be a winner. But if they're not, we violated the criterion. So let's do our head-to-head matchups. So we have AB, AC, AD, BC, BD, CD, all the head-to-head matchups. So this is determining if there is a candidate who's undefeated head-to-head. Looks a lot like doing the pairwise comparisons method. Okay. We're just trying to determine if anyone wins all of their head-to-head matchups. So with A against B, A is always going to get these 20, right? Because these 20 people have A in first. Hi. And then B is going to get, does B get everything else? Yeah, B actually gets all the remaining votes, because every other column B is ranked higher than A. Right? So of 36, 20 go to A, and the remaining 16 go to B. So even though B got every other vote, A won here, because A has a majority. Yeah. So that's going to happen with all of them. With all of A's matchups, A is going to win, because A has the majority of the votes. There aren't enough votes left for someone else to beat A. because there are fewer than half the votes remaining. So even if candidate C or candidate D got all of them, they still couldn't beat A. So I'm not even going to finish doing all my pairwise comparisons because now I see that candidate A is undefeated. Candidate A is an undefeated candidate. They win all their head-to-head matchups. So and candidate A won, right, using the plurality method up here. Candidate A wins, and they're a Condorcet candidate. So have we violated the Condorcet criterion? No, that's exactly what the criterion says should happen. A is undefeated, they should win. They did win, so everybody's happy. So no violations here. Okay, so now we have another election, number 3. I want to know if the plurality method violates majority or Condorcet in this election. So how many voters are there here? 55 votes, which means 28 for a majority. Okay. So let's do the plurality method. I'm just going to determine the winner by counting first place votes. So candidate A has 16. B also has 16. Okay. And C, 11, and D has 12. Okay. So who's the winner? Tie with A and B. Tie between A and B. And did we violate the majority criterion? It doesn't apply. Can you explain why, Ryan? Yes. In order for the criterion to apply, someone has to have a majority, right? The majority criterion says that if someone has a majority, they should win. It doesn't say anything about what should happen in the event that no one gets a majority, right? So in this case, since it takes 28 votes to get a majority, nobody has a majority, so there's no violation. Okay? The only way to violate the majority criterion is if someone has a majority and loses. So this has no violation. Does that make sense to everybody? Okay, so let's look at the Condorcet criterion. We're still looking at the plurality method, so we're just going to like keep the results in our memories from up here. And I'm just going to see if there's a Condorcet candidate, if there's an undefeated candidate. So I have to do all my head-to-head matchups, AB, AC, AD, BC, BD, CD. All my head-to-head matchups, figure out if there is a candidate who's undefeated. So let's see, A versus B. These 16 are going to go to A. The next 3 columns, which also add up to 16, would go to B because they're all have B in first place. Now the last 3 columns, we have to decide they don't have A or B in first place, but they still are going to be forced to choose A or B. So these 8 people would choose B because they have B ranked above A. And these 3 people would choose A because they have A ranked higher than B. And the last 12 people would also choose A. So we're going to have 8 more for B. And then 3 more and 12 more for A. So that means that A is going to end up with the more votes. Okay, so A wins that matchup. All right, how about A versus C? Anybody have results already? C wins? Okay. Okay, so now I don't even have to bother doing A's last matchup because I now know A is not undefeated. Right? So I'm not even going to bother doing A versus D. Because I'm just looking for an undefeated candidate. I'm not doing the whole pairwise comparisons method. So A is not undefeated. C has a chance at being undefeated. So let's do C's other matchups here. B has no chance. I guess D could have a chance. So maybe we might come back to this if we have to. All right, let's look at B versus C. So these 3 would choose B. These 4 would choose B. But these 9 would choose C. So I've got 7 and 9 so far in the first 3 columns. And then in the next 3 columns, they all have B in first place. So all 16 there are going to go to B. And then these 8 people would choose C, C, and C. The last 3 columns all go to C. So that's 15 and 8 is 26. So what's 15 and 8? 23. Okay. So 23 and 9 is 32, which is more than 16 and 7. So C wins that matchup. So C has now won 2 of its head-to-head matchups, right? So we're going to check its third one and see if it's undefeated. C versus D. All right, so let's see. C versus D. This first column goes to C. They get 3. Next column goes to D because D is ranked above C, so they get 4. And then the third column goes to C. So does the 4th and 5th, so that's 11 more. And then we have C, C, C. So these 3 columns all go to C. 5 and 8 is 13, 16. And then the last one, 12, goes to D. So it looks like C is the winner here. So I have now seen that C won all of its head-to-head matchups. C is undefeated. So we say C is Condorcet. And the Condorcet criterion says that if you have an undefeated candidate, they should win, right? Did candidate C win? No, with the plurality method, we had a tie between A and B, right? So this election demonstrates a violation of the Condorcet criterion because we had a Condorcet candidate, C. C is Condorcet, but C didn't win. So we violated the Condorcet criterion. Would it matter if, say that again? Oh, yeah. Even if A or B had won all their head-to-head matchups, we would still say there's a violation. Yeah. Yeah, so really we didn't have to do all that work. Yeah, good point. Anybody have some remaining questions on this? Yeah. Okay, let me just I just want to point out the homework first, because I didn't mention it yesterday. So the homework for this class was to finish that voting activity, but I wasn't going to collect it. And then we always do the My Math Lab assignment, right? But here it also says, additionally, do problem number 2, parts A through F from the textbook assignment below. So that is this. So I also want you to do that problem out on paper and hand it in next week. All right, so homework question. That's okay.
There was a question that asked this. It asked about there was something
IIA, yeah.
It did not say which candidate was dropping off.
Okay.
But
Okay, so just to summarize what we've done so far, we have seen 4 different methods of vote counting. We had plurality, Borda, plurality with elimination, and pairwise comparisons. And we saw 4 different criteria to decide if a vote counting method is fair. The Majority Criterion, the Condorcet Criterion, Monotonicity Criterion, and Independence of Irrelevant Alternatives Criterion. So these are 8 pieces of information that you need to be familiar with. Yes, question? Yes, IIA is the dropout one. Yep. So I want to point out that on page 9 of your packet, I'm going to scroll back here so I can show it to you. So there is a voting method summary, okay, page 9. So there is a quick summary on how to do all the 4 voting methods and what the 4 fairness criteria are. So this is a handy little thing to have like when you're preparing for your test. Okay. It's on page 9 of the packet that you're looking at. Find where I left off here. Okay. So make sure that you are familiar with and understand those 8 things. It's a summary of what we've done so far. All right, so even though some vote counting methods violate some fairness criteria, our vote counting methods don't violate all the fairness criteria. So for example, I want to think about the plurality method. Somebody remind me which one the plurality method is. Stephanie? Nope. Close. The most first place votes. It doesn't require a majority, but it's close to the majority one. So the most first place votes wins. So is it possible for the plurality method to violate the majority criterion? Is it possible when you're using the plurality method to have someone get more than half the votes but lose? Did you say no there, Corey? How come? Can you explain? Okay. Yep. Uh-huh. True. So you can win without having a majority with the plurality method. Does that mean that we violate the majority criterion? No. Right. The only way to violate the majority criterion is if someone has a majority and loses. So you're right, it's possible to win without a majority, but that doesn't violate the majority criterion. It's probably it's definitely a drawback of the plurality method, but it's not a violation of the majority criterion. So let's make up a quick election. Here are the results. A gets 20 votes. B gets 9, and C gets 5. How many total votes are there in this election? 34. 29, yeah, 34. Which means how many do you need for a majority? 18. Does anybody have a majority? Yeah, A has a majority, right? So, and A wins because they have the most, right? Is it possible for a candidate that has a majority to lose? Not with plurality. So let's say there are 100 votes. There are 100 votes in election. So what would a majority be? 51. Good. So we're going to give some candidate, we'll say candidate A has 51 votes. Is it possible for anyone else to win this election? No, not with plurality, because A, there aren't enough votes left. Once you give someone a majority, there aren't enough votes left for anyone else to beat them. So even if there was only one other candidate running, right, Or if there were 5 other candidates running, but only one of them got all the remaining votes, right? There's only 49 votes left to go around. Nobody's going to be able to beat A. Okay, so A is now unbeatable. Right? So if you give a candidate a majority of the votes, they will always win using plurality. So that means it is not possible for the plurality method to violate the majority criterion. It will always satisfy it. If someone gets a majority, they have to win. There's no way that they could be beaten. So plurality always satisfies the majority criterion. If someone gets a majority of the votes, they will definitely win if this is the method that we're using. How about, is it possible for the method of pairwise comparisons? That's with all the head-to-head matchups. Is it possible for that method to violate the Condorcet criterion? Yeah? Okay, let's do an example. Quick example, we'll do 4 candidates. So we have AB, AC, AD, BC, BD. So remember the Condorcet criterion, oops, CD. Thank you. Remember that the Condorcet criterion says that whoever is undefeated in their matchups should be the winner. If there's someone who's undefeated, they should be the winner. So, and the pairwise comparisons method counts up the number of times you win a head-to-head matchup. So pick any candidate, we'll have them be undefeated. A or C? Okay, we'll go A. A wins those 3. So A gets 3 points, right? In the pairwise comparisons method. Now, if I count up B and C and D, what's the very most matchups that B could win? 2. What's the very most matchups that C could win? Well, assuming B won this one, yeah. But the most they could win is 2, because we don't really know who won that one. Same thing for D. The most they could win is 2, because they all lost to A. So nobody can beat A now, right? So at most 2 for anyone else. So if one candidate's undefeated, is it possible for anyone else to beat them? No. So the pairwise comparisons method always satisfies Condorcet. Because if someone's undefeated, now they're unbeatable. Nobody could beat them if someone wins all their head-to-head matchups. So we say pairwise comparisons always satisfies the Condorcet criterion. It is impossible for anyone to win all their head-to-head matchups and lose if the method we're using is pairwise comparisons. That make sense? Okay. So here's our complete fairness table. In general, violates means that the method violates the fairness criteria sometimes. It's possible to rig an election where it violates the fairness criteria. And satisfies means that the voting method never violates the fairness criteria. Always satisfies it. Okay, so as we can see from this table, none of the 4 voting methods satisfy which of the criteria? Dropout, yeah. Okay. Is there a method that satisfies the dropout criterion? Sure, definitely. However, we have this Arrow's impossibility theorem, that says there is no voting method. If we're using preference ballots, there is no voting method that will always satisfy all 4 of the fairness criteria. So we could devise one that satisfies dropout, but it would violate something else. So this is really surprising, that there is no fair way to conduct an election, right? And this is a nice quote from our textbook that says, no matter how hard we try, democracy will never have a perfectly fair voting method. And the potential for unfairness is built into every election. But this does not mean that every election is unfair, right? Just that it's possible that something unfair could happen. Or that every voting method is equally bad, right? Nor does it mean that we should stop trying to improve the quality of our voting experience. It does mean that we have to accept trade-offs in choosing one election method over another. For example, we might try to pick a voting method that would eliminate tactical or insincere voting. Right? So, do you guys remember tactical insincere voting from a couple classes ago? Where you might switch like your second and first place vote because you know your first place guy has no chance of winning, and you just try to prevent the person you really don't want from winning. So you like settle for your second choice. So it turns out, here's another theorem. Some other famous voting theorists said that that's basically impossible. You can't eliminate insincere voting. So the only 2 kinds of systems that aren't vulnerable to tactical voting are a dictatorship, where one person has the only vote. I'm the only person who gets a say. So that means I don't have to vote tactically. I can just go with my heart because I'm the only person that matters. Or a random system. Okay, a random system is where you don't tell the voters how the votes will be calculated, how the votes will be counted ahead of time. Okay, so you just give everyone a preference ballot, but you don't say, I'm going to use pairwise comparisons or I'm going to use plurality. It's a surprise, which has its own drawbacks, right? Because that could be seen as yes, they could do all the counts and then just pick the outcome that they like the best, right? So that could be seen as very shady, like not telling people how the votes will be counted. So basically, it's impossible to eliminate tactical voting. Okay. But you can still look for systems that are less vulnerable to tactical voting. And a number of other fairness criteria have been developed and discussed. We have studied 4 of them in depth. This is just like a few more. I just wanted to show you because it's kind of interesting trying to decide like what makes an election fair. So this first one is called the Condorcet loser criterion. So it says that if a candidate loses to every other candidate when you do all the head-to-head matchups, so if there's a candidate who's, what's the opposite of undefeated? Like very defeated, right? Right, like if you are on a team and you go 0-3, right? You lose all your games, you always lose, right? So if you are a Condorcet loser, you always lose to anyone else. This criterion says that you should not win the election. Seems fair, right? Yep. And then this clone independence criterion, it says that if there are 2 identical candidates in the same race, the outcome of the race should not be affected. So if we add a twin, so let's say I run an election and the results are C, A, B, D, right? And then I add a twin. I add in B's twin to the election. We'll call it B prime. B prime, okay? If we put B prime in the election and recalculate the votes, B and B prime are identical. People like them the exact same amount. They would rank B prime right where they had put B. They're twins, right? So C should still win, according to this criterion. If you add a candidate's twin into the election, the winner should remain unchanged. Does that feel like an important thing for fairness? Yeah, maybe. I don't know. Seems a little less important than some of the other ones to me, but I don't know. And then there's a participation criterion, and this one says that not voting should not help your preferred choice win. So for example, Ian Winokur gave me this example. He was at a town meeting where there was a vote being put forth, and like 90% of town residents were behind this motion, wanted it to pass, but there were a few very vocal residents who were against it. And they stood up and spoke, and that's part of the town meeting process. But it was this proposal was coming to a vote, right? But in order to hold a vote in a town meeting, part of the town bylaws stated that at least 5% of the town population had to be in attendance. So the people who were really against this proposal said, I want to count. I want you to count, because we can't hold a vote unless 5% of the people are there. So they counted, and there were a few people short. So people would get on their phones, you know, get down to town hall, we need you here so we can take a vote. And a few people showed up, so that they had 5%. And then those people who were against the proposal said, well, we're leaving, right? So that they thereby preventing a vote and ensuring the outcome that they wanted, right? So feels like there's something wrong about that, where not voting, like pulling yourself out of the process, should help you win, right? That there feels like there's something weird about that. So that's called the participation criterion. Okay, not voting should not help your preferred choice win. So here are a few overall conclusions from our study of elections. No voting method is perfect. Pairwise comparisons may be the fairest. If you look up at our table here, pairwise comparison satisfies 3 of the 4 criterion that we studied. There are other criterion, so it's hard to say, you know, that it's the fairest, but in what we've studied, it may be the fairest. A number of voting methods are improvements over the plurality system. Okay? And the plurality system, whoever gets the most votes wins, is the one that we use to elect most officials in the United States. Why do you think that we use that one so much, even though there are better ones? Because we're stubborn. Mike, what do you think? It's easy. Yep. And I think aside from just being easy, it's easy for people to understand. And I think when you're trying to get buy-in from the whole electorate to participate and believe in the results, they have to understand the method of counting, right? Otherwise, it just feels like magical. Yeah, very few. Very few. Yeah. So we have a brief biography of 2 important figures in voting theory. This is like an incredibly long name, blah, 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 Condorcet, last name. He was a French mathematician, philosopher, and political scientist. He advocated free and equal public education, equal rights for women and minorities, and he was the first to propose a system involving pairwise comparisons. Okay, so such systems are often called Condorcet voting, when you do all the head-to-head matchups. And he was a strong opponent of the Borda system that had some popularity at his time also. Leading figure in the French Revolution, he eventually fell into disfavor and died in prison. And Kenneth Arrow, he is the economist / mathematician who realized that there is no fair voting method. There is no method that will satisfy all 4 fairness criteria. So we have a good amount of time left in class today, and I have reserved it for you to work on your projects. So hopefully you have collected all your data, and if you haven't, this could be a good time for you to just walk around the room and get people's opinions on your question. And if you have any questions, ask a classmate or me, and I will help you work through the project.